welcome to The Explainer. Today, we're prying open the black box of artificial intelligence to explore exactly what the world's top scientists are still struggling to teach machines. We constantly hear about how incredibly advanced neural networks have become, but today, we're flipping the script. Our focus is firmly on understanding what AI absolutely can't do yet. You know, if you just read the mainstream headlines, you'd think AI is practically omnipotent, right? But looking at the actual 2026 proceedings of machine learning research reveals a completely different, highly constrained reality. We're going to look directly at the papers presented by top researchers across the globe, and what you'll find is that the bleeding edge of computer science isn't just about giving AI new powers. Actually, it's heavily focused on desperately trying to fix some deep structural blind spots. Here is our roadmap for today. We'll be hitting 1. The AI reality check. 2. The AI memory problem. 3. The bias blind spot. 4. Correlation is not causation. And 5. The road ahead. Let's jump right into breaking down thousands of dense academic papers into 3 core human-relatable hurdles. Section 1. The AI reality check. Examining the bleeding edge of ML conferences. So, the crucial point to start with is realizing just how much brain power is currently dedicated to fixing AI's foundational flaws. When researchers are publishing literally volumes of papers on a topic, like at the massive third conference on parsimony and learning recently held in Germany, it is a huge sign that the problem is far from solved. Instead of taking victory laps, these proceedings are filled with warnings, deep error analysis, and strategies to mitigate a terrifying concept called model collapse. Moving on to Section 2, the AI memory problem, or simply why AI forgets. Let's talk about the stability-plasticity dilemma. This was a massive focus at the 4th Conference on Lifelong Learning Agents. It basically describes a machine's inherent inability to gracefully add new facts to its existing knowledge base. See, when a neural network is highly plastic, it learns new things super easily. But the trade-off? It completely loses its stability, meaning it essentially overwrites the data it just learned yesterday. This leads perfectly into a phenomenon researchers call catastrophic forgetting. Think about how we learn as humans. It's a lifelong process, right? If you learn to play tennis, you don't suddenly forget how to ride a bike. You just integrate the new facts. But with AI continual learning, teaching a model a brand new task often completely and catastrophically overwrites the old one. Imagine spending months learning French, only to suddenly realize you've completely lost your ability to speak English. That is the actual reality of current AI architecture. For a long time, scientists thought they had a solid fix for this, but get a load of this real paper title from Mahatmi and colleagues. Replay can provably increase forgetting. No way, right? It turns out that even our best workaround strategies, like replaying old data to the machine while it learns new data, can mathematically end up making the AI's memory even worse. It fundamentally corrupts the network's understanding. And honestly, the fragility doesn't stop at just natural forgetting. Another major paper from Pollack and team highlights that beyond simple memory loss, we have this massive issue called single-task data poisoning. Basically, a tiny injection of bad data doesn't just teach the AI one single wrong fact. It spreads. It fundamentally corrupts the entire foundation of the system's ongoing memory. It is literally like a virus that permanently damages the machine's ability to retain accurate information over its lifespan. Section 3. The bias blind spot. The flaws in multimodal AI. It is absolutely crucial to understand that AI does not exist in a neutral, objective vacuum. Systemic bias happens when these systems inherently produce prejudiced or skewed results. And why does this happen? Because the machine is absorbing all the subjective flaws of its creators. From flawed training data to cultural misalignment, the AI is essentially holding up a mirror to our own human imperfections. This exact issue was the entire focus of a specific AAI 2026 workshop in Singapore. The sources of this bias are incredibly subtle and notoriously hard to weed out. Take this dramatic paper title from Hu and colleagues. They found that even the personal risk preferences of the individual humans sitting at a desk, labeling the training data, inadvertently inject systemic bias right into the AI. If the human labeler is naturally risk-averse in how they categorize an image or text, the resulting AI becomes permanently skewed by that specific human psychological trait. We're seeing a massive list of unsolved vulnerabilities pulled straight from the workshop proceedings. We're talking about cultural representation bias in large language models, alignment divergence across entirely different societies, and physics-based cross-modal biases. There's also expert collapse in simple multimodal mixture of experts, where different parts of the AI are supposed to handle specific tasks but completely fail to coordinate. What you really need to take away here is that recognizing a blind spot is incredibly different from actually fixing it.
Section 4. Correlation is not causation. The reasoning hurdle.
If you take away anything from this explainer, I really want you to remember this concept: causal calibration. This is an AI's ability to understand why something happens, true cause and effect. Current AI is an absolute master of pattern recognition. It easily recognizes that two events frequently happen together. But it fundamentally lacks true causal reasoning. It knows that umbrellas and rain appear in the same pictures, sure, but it doesn't intuitively grasp that the rain is what actually causes the umbrella to open. For a while, the tech industry thought they could just build bigger models to solve this. But research from Engelberger and team at the 5th Conference on Causal Learning proves that totally wrong. Their paper shows that just making a large language model bigger doesn't magically grant it the ability to understand cause and effect. Instead, it just fakes it better through statistical information interpolation, which basically means it's just guessing the next logical word with higher accuracy. The lights are still off when it comes to true comprehension. Top scientists are still actively fighting to help AI differentiate between a real causal link and a completely random, spurious correlation. They're struggling with retrieving correct causal orders when the AI is fed inconsistent knowledge and handling confounding variables in observational data, meaning those unexpected outside factors that mess up the data and create false patterns. A machine that cannot tell the difference between a coincidence and a direct cause simply cannot be fully trusted to make critical decisions in medicine, law, or infrastructure. Which brings us to Section 5, the road ahead, reaching the next frontier. So tying all these dense academic findings together, where does this actually leave us in the future of AI development? Well, the sheer volume of 2026 research dedicated to fixing compositional failure proves that the road to artificial general intelligence is currently blocked. True parsimony in learning, the elegant, efficient mastery of information, requires models that don't just parrot back data. They must maintain stability without catastrophic forgetting, they must remain unbiased against human annotator flaws, and they absolutely must evaluate true causal mechanisms. Because if we don't solve these things, we face massive consequences, like those warned about in this paper by Zhu and colleagues. They're researching model collapse. This happens when models start training on data generated by other flawed models. When that loop begins, they risk a complete and total mathematical collapse. It's a stark, mathematically proven reminder of AI's current fragility. Understanding what AI can't do yet is the true key to understanding where the technology is genuinely heading next. So I want to leave you with this final provocative thought. If the global scientific community is working this hard right now to fix memory, eliminate bias, and teach true causal reasoning, are we really prepared for the day the science finally bridges the gap between today's hype delusion and tomorrow's omnipotent reality? Thank you so much for joining me on this explainer. Keep asking questions, and I'll catch you next time.